Hello everyone, this is Madhu Mohan Nelamane. I work for the SLE and CASP networking in SUSE. I've been a developer there for last 5 years. And welcome to this session on Introduction to Edge Computing. So this session is basically an introduction when we are focusing on technical challenges and some of the fundamentals of the technology itself. It's a technical beginner presentation and only very basic knowledge about cloud computing and containers would be sufficient. So going ahead, this is our agenda for today. So we'll go through some use cases to understand why the buzzwords about edge computing even exist. Then we try to define edge computing and separate it out with from different other buzzwords we hear about all the time. We will look at a typical edge devices, and then we go through general architecture and components of edge computing, a brief look at the networking requirements. Then we learn a little bit more about the additional services, and finally we'll go through Kubernetes as an example of an implementation of edge computing ecosystem. So with that, let's begin. Why edge computing? So we'll say let's come back to this slide a little later again. So these are the typical applications which we have seen. Augmented reality, connected cars, basically connected autonomous cars, video acceleration in real time, be it surveillance, real-time content delivery, say for something that works like an instant replay of key moments of your favorite sport immediately after it happened and on your mobile device while you're just outside the stadium. So that's something um, this would enable. In all these cases, we are talking about massive amounts of data and sometimes multimedia being processed and delivered in real time to your devices. So your service provider has to deliver the content onto your device in real time and also has to make sure he collects payment for doing that and has some options to configure your service. The only option to do this with the current infrastructure is to transfer the entire data all the way to the cloud or data centers and process through the service chain in the data center, deliver the content through its content delivery networks. It's going to take a lot of time, and it's definitely not going to be in real time. So, and as the number of such devices that can generate and send data across the cloud increases, which is happening today exponentially, then it's not realistic to offer such services with huge transmission delays. Moreover, some of these services also require location-aware features, like for example, your connected cars example that we have here. So there are a few more examples here where there is a lot of data, not so massive, but enough to disrupt the kind of use cases that it enters into. So, but involves real-time processing. Very basic things like smart homes, smart offices, and smart factories. So wherever we think about IoT use cases involving um, IoT devices, we also think about edge devices. So now we'll go back to the slide where we were talking about why we have edge computing. Um, So with evolution towards 5G and IoT consumer devices in so many applications that we just saw, there is a large amount of data that is being generated, and it's a big burden to transfer all the data all the way to the data center and do our compute. Some of it must be shared somewhere close to the devices, and it's also important because real-time needs of some applications will desire that. And some of the applications involve data analytics, which require data on the spot in the location and make decisions in real time. And why we're talking about it right now is that there are now now technologies and an ecosystem where this kind of use case is possible. So there are currently several open source and standards bodies which talk about edge computing, be it OPNFV, CNTT, uh, and Cloud Native Computing Foundation, Edge Foundation, and even the European Telecommunication Standards Institute, ETSI, MEC, etc., which are talking about democratization of computing resources. And so there is a global interest in pursuing edge computing use cases, and that's why it's quite important right now. So let's understand what is edge computing. So these are again the list of use cases you can think about and the domains that it's going to touch. So what is edge computing? First of all, let's differentiate among various buzzwords. The cloud versus fog versus edge versus mist. Um, so one of the there are different definitions about these technologies in different forums, but one particular explanation was quite impressive for me. Um, so what it said is the cloud and mist are basically the two ends of the continuum, and in between these two, you have edge and fog computing um, concepts. So the cloud sits at the data center, while the mist computing really deals with the consumer devices, including uh, your mobile phones or smart bulbs, etc. So everything that comes in between is can be either edge or fog computing, and in a way you can differentiate between edge and fog by classifying all the devices that are absolutely the last mile. That is just the next device which you connect to the device. So that would be something that you would be um, calling edge computing. That's the way we can differentiate. Now, this is a Wikipedia definition. Edge computing is a distributed computing paradigm which brings computation and data storage closer to the location where it is needed to improve response times and also to save bandwidth. Um, so here is a picture which gives an idea about where exactly the edge computing sits. So here you have all the Internet of Things, the devices which are connected to the Internet, and at the end is the data center and cloud, and in between you have uh, edge devices which basically do real-time data processing, some analytics application, and they also enable machine-to-machine communication and so on. So uh, that should basically clarify what this edge computing is all about. So here's a list of advantages. Improving performance, that's never going to end. It's always important to improve performance as our use cases keep increasing. The number of devices it influences. Compliance, some of the SLAs that mandate a certain bandwidth and certain response times for your applications. And then privacy and security, that's a difficult one. So on the one hand, there is a risk of exposed devices, but at the same time, we also reduce data transmission time. Therefore, we can reduce the risk of air-gapped hacking, that is hacking when the data is being transmitted to the cloud. And so reduced operational costs, of course, because when you are thinking of replacing, you are thinking of replacing low-cost edge devices rather than huge servers that are typical of data centers. And also, um, if you could let the bad hardware stay for some time without affecting your services by distributing the services delivered across multiple edge devices around, you might probably delay your hardware invoice with a small compromise, which is possible in case of edge computing. And also ultra low latency computation, if you want real-time results on some data that you gather on the location, and location aware computing, of course. Um, so there are so many advantages. So what is an edge device? So let's look at a few edge devices. So what should edge device do? So when I say edge device, apart from the computation, it itself can be treated as a gateway. So a gateway because it acts really as a gateway between the cloud and the rest of the devices where the applications are to be serviced. What should it provide? It should provide facilitate. It should facilitate distributed computing. Um, so what does that mean? It should provide data storage and protection. It should provide protocol support. There are devices which are actually running with different kinds of protocols. It could be Zigbee or Wi-Fi or WP-LAN, MQTT, and some of them probably just require HTTP. So, and there are special protocols for sensor networks if your devices are IoT devices used in industrial automation kind of use cases. So they also should provide data caching support to speed up computation. And this is not this comes with a few considerations like how do you cache, what amount, and where do you cache, and what is the kind of cost versus cache cost benefit analysis that you need to do where you see whether caching is really worth the gain. So there's a lot of research and results on defining a proper trade-off for different needs. Data persistence. So it should provide sort of temporary and permanent data store for backup at the edge devices. And this was not the, these devices were not designed for data storage. They were basically things like routers and switches, basically traffic managers and small servers, which need not be designed for massive data storage. So that's something which we need to consider. Um, and network aggregation, which is basically what most of the devices already do. And they should do this along with other responsibilities that they are taking up now. And they also should allow for computation offloading. So they are supposed to host computing power from uh, to do some of the computation at the edge itself rather than trying to push all the data to the cloud. But some of the devices come with its own challenges like limited storage and limited capacity in terms of uh, um, CPU power, and so decisions have to be made by end user applications and services to choose among local execution, what needs to be executed at the device itself, and how much of it can be partially offloaded to the edge gateway, and how much of it needs to be computed in the data center. So there has to be some balance, and it's something that every solution has to undergo. So generally anything that sits connected to the end devices are basically uh, used as edge devices. The routers, switches, some access devices in case of mobile networks, and some general purpose servers which are close to the device. So that's about the hardware of the edge device. There is nothing new. It's just that we need to adapt to the new use cases. And let's go to the software aspects. So for most services, the current infrastructure, we define some of the functions inside the user equipment, your mobile phone, for example, and some of the services are provided by the data center. So with edge computing, we have a middleman. So the idea is basically to share some of the responsibilities with edge gateway. Some of it from user equipment and some functions from data center can be moved and performed in edge device. So user equipment will still have to do some of the basic tasks like user authentication and uh, or initiation or identifying which network to connect to. So these are something which still the user equipment has to do, and data center will still have to contain the service provider details as to which um, users are eligible for what kind of services. It should maintain the list of users and maintain the number of edge instances that are basically running the services. Um and edge device now can contain some part of authentication, and it can cache user content, and it can synchronize between edge between the client and the uh, cloud backend services, can provide good quality of connection to the client because it doesn't have to always hook into the data center, and it can of course provide a lot of advantages in terms of computation. So based on the services that we intend to provide, we initially need to select which edge devices that are already available can be used for our services. So edge host selection is an important thing that we need to pay attention to. That's based on deployment model. Um, how many nodes do you need and how close they should be available, and what kind of compute power and what kind of capacity is required. Then there are virtualization requirements, and all issues that we think of when we were actually talking about virtual machines, from KVM or just the regular containerized workloads. So we will have to think about those issues here again. Now there are latency requirements. Um, of course, the location and mobility requirements, because some of the services that we need to run are on devices which are in constant motion. So the problems of handover from one edge device to another edge device as the device moves. For example, when you're driving in a car and your application is a service on your infotainment system in your car. So then there are issues in terms of handover from one edge device to the other edge device, which is closer to your new location. So, and there are platform services. Some of the what kind of architecture support should be available. Whether the operating systems need to uh, be enhanced to provide the kind of services and applications that you want to run. And then, of course, the network connectivity. So to the internet, to the data center, among other edge devices, to end user devices, to other external entities if you are connecting to them, and the level of security requirements needed, the QoS requirements, quality of service, then interface required. So whether your devices are an on-premise equipment and connected through wireless or wired. So there are quite a few considerations when it comes to network connectivity. Then there are access requirements, whether if it's configurable, is federation possible? Like, can you log in onto your service from one of your devices, and can you have a single sign-on facility where you can access all services that you are entitled to based on a single signature, and you don't have to remember 100 passwords for um, driving your car or using your mobile phone. So, and of course, there are storage requirements. How much storage the edge host should support and in what way. Now, let's look at briefly at the edge architecture. So, here's a high level view where it's pretty clear that edge gateway kind of sits at the center of all the things that are happening around the public cloud, the private cloud, and all the internet of things. So everything needs to sort of interact through the edge gateway. Um, so the European Telecommunication Standards Institute defines a framework. It looks something like this. And So the MEC host itself um, includes the platform to the host to host the application, and the host management and virtualization infrastructure. And the system level is basically deals with services that utilize multiple hosts, and the entities that they are concerned about are basically services, and they also decide how these services will be provided to user equipment. And then the hosts are connected through various forms of networks at the which is the backbone of the whole ecosystem. Wired, wireless, local networks, external networks, or 3GPP mobile network, and similar uh, infrastructure. So based on this framework, ETSI also has a proposed reference architecture. Um, so the mobile edge system works on the basis of an orchestrator to orchestrate all the services, um, talking to the edge platform manager, which in turn communicates to the edge platform. Um, that so the edge platform is something that provides the virtual infrastructure manager with the required resources, and saying what kind of resource do we need, whether we need containers or virtual machines, and what would be the capacity to um, be used for the kind of service that we want. A plan that is populated by the mobile edge orchestrator will be executed on the virtualized infrastructure through the virtualization infrastructure manager. And the edge platform itself provide the required environment running for running the services. So application services, or even the mobile services or location based services, in case when mobile networks are involved, requires a different kind of services to be available. And it also hosts a service registry to uh, say what services are available on the platform, so that the manager can um, basically have an idea about where to address when a certain orchestration requirements comes to it. So to summarize, so edge application can now utilize these components, run on top of virtualized infrastructure as virtual machines or containers. So these entities are orchestrated by the host level management system blocks and provided with additional services by the edge platform and platform manager. So a small look at the networking. So we see a lot of things that are different when it comes to networking for the edge computing. So one of the key requirements is, of course, providing low latency and traffic slicing capabilities. When so traffic slicing itself is a concept that requires a separate session on its own. It basically allows users to um, have a single identity and create a network slice and access all the services for that particular identity. So the identity could be an individual or an institution or um, a business. So traffic slicing facilitates that capacity. And there are 5G network functions which are important when you're talking about mobile services, orchestration, and connections to the cloud. So these are things that networking should be concerned about. And there are a few other new challenges, like mobility that we already talked about, sustained connectivity, and then there is the issue of east-west traffic management. Apart from the user equipment talking to the edge devices and from there to the cloud, there are also a lot of packets being transmitted across edge devices. So that needs to be managed. and location consideration, making sure the handovers are fine, and security. Um, so data storage, as we already talked about, the fact that the edge devices are not meant for massive data storage, and they need to be adapted to that. They're mostly traffic forwarders as of today, and they need a certain adaptation towards data storage and huge data analytics. So considering these challenges, there is also a need for probably a dedicated operating system, edge operating system. You might have a look at the presentation of one of my colleague who has talked about Edge OS. And these edge computing devices, which are special purpose devices for certain function, are now to be treated as general purpose computing devices. So these are challenges we have already discussed. So some additional features which are essential and we can go a little deeper into. So federated identities, as we talked about, where it provides a single sign-on facility, and basically a user proves his identity along um, and is assigned a role and requests access to services from the system by establishing a trust relationship with the system. And the important aspect is that he's able to use single sign-on to gain access to all services he's eligible for. And that should be populated across all the edge hosts where the services are um, running. So the next aspect is basically resource caching. So it provides a huge advantage in edge computing use cases since it reduces the frequency of communication to the cloud. Several caching algorithms are available, and consider aspects like what and where to cache, replacement, eviction strategies, performance optimization. Basically, a detailed cost benefit analysis for each type of caching needs to be considered. Um, then computation offloading. We need to make a few crucial decisions on what computation can be and should be offloaded, and what type of offloading should be chosen for the type of service that we want to provide. And again, a cost benefit analysis has to be balanced. So here are some examples of what can be offloaded, like information collection, just get data gathering from various devices, and then probably synchronizing it with the cloud at the end of the day. Is just one example. And cognitive computing, some kind of analytics, some AI algorithms that you want to run on the edge device to handle some use cases, maybe location aware use cases, or traffic control kind of things, which um, sometimes require AI algorithms. And request handling, so is also one of the things which can be just handled in the edge. So, but some of these can need not be completely offloaded to the edge device. There can be local execution, partially executed at the client, completely offloaded, or partial offloading, where some of the things can be done at the edge and the rest can be again done at the cloud. Um, so then there are challenges about provisioning, management, and operations um, of edge devices and the services. Uh, so if the services need major customizations and optimizations on the edge device, and then that becomes a challenge. And there are also issues with respect to service delivery based on uh, how the how the service is being allotted across various edge devices. So Now we see an open source implementation which uses Kubernetes, um, and it depends on Mosquito and Docker as other open source projects. Um, as we know about Docker and Mosquito is something that provides a messaging service for services, especially those running on the edge. So if you look at the website of KubeEdge, which is the project that we are planning to do, we're thinking of discussing. So here are a few features. Like it's fully open source, offline mode support, scalable. It is apparently resource optimized, platform agnostic. You can run it on ARM or x86 kind of architecture. Um, so it's heterogeneous in terms of CPU architectures. It also supports data management and analytics API. Um, so SDK based development. So it's easier to integrate new devices and new services on top of this. Um, s- so these are the few features which we would like to see in any open source implementation of the Edge ecosystem. So here's a basic architecture. So there is of course the cloud part and the edge part, something that a part of it which runs on the cloud and where the Kubernetes API server run and interacts with the administrator. And there's the other part which runs on the edge device, which talks to the devices either through MQTT protocol broker to the device or through a simple plain HTTP requests. Um, so here we're just showing two of the possible ways of interacting with the edge system, and there can be multiple of them. As we discussed, there are different protocols for different devices, and assuming just these two will suffice may be trivial. And as we can see, multiple runtimes are supported: Docker, Containerd, or CRI-O. And the device twin, which is one of the most important component here, um, eh, also known as the device manager, keeps track of all the devices that the Edge platform has access to, and through the Edge hub, it constantly synchronizes and with the cloud. The cloud hub receives the communication from the edge part, and it keeps um, data of the edge devices available and the state of the edge device and the devices um, that are in the ecosystem. So it basically keeps an inventory, and this synchronization keeps happening at frequent intervals. Now, so this slide basically summarizes what we spoke about, the architecture diagram. So this was just an example of the of Cube Edge, of an edge implementation in the open source ecosystem, but there are several other efforts in different places. Edge Foundry and Home basically deals with smart home kind of applications, and there's also other aspects where it's possible to uh, use service mesh kind of technology on edge devices to be able to have a control plane and data plane kind of interaction. Um, so service mesh control plane, which is Istio or Envoy, which acts as the data plane proxy, which can run on the edge devices. Oh, so that kind of combination also can be done, and there are different other architectures that are being proposed in various forums. So that kind of concludes for the technical presentation for today. So here are a few links that I have taken some of the pictures from, or some of the, if you want to go deeper and explore. Um, and to get a broader perspective of the topic. And apart from that, I also refer to few papers, um, and especially the ETSI standards documents are extremely helpful in if you want to access more information about what's going on in the edge computing. Most of these are referred to as multi-access edge computing, and any of the articles and standards that are published in and reference architectures that are published in this forum could be very helpful. And so if you have any questions, I would like you to reach out to me on my email ID or the team email ID, who also have a lot of information about some of the topics, and any feedback on this presentation is welcome. So, thank you.